Okay, today we're going to be looking at the difference between linear and exponential growth. And we've really already seen this in the first unit with the difference between simple interest and compound interest. But now we're just taking this idea of these two types of growth and looking at them in different situations. Problem number 1. Starting in January of 2012, the number of animals at the local shelter has increased by 10 each year. If the animal population was 130 in January of 2012, what is it in December 2016? And is the growth linear or exponential? Well, the first thing I want to do is notice that this is increasing by the same number each year, the same absolute amount each year. So that means I have a linear growth. Okay, now I'm starting off the year 2012 with 130 animals. And then I'm going to add 10 more animals that year. So at the end of that year, I have 140. So the beginning of 2013, I have 140 animals. I add 10 to that, and I get 150. And so on. So let me complete that table real quick. Okay, and there we can see the rest of the table for problem number 1. At the end of 2016, we end up with 180 animals. Okay, going on to problem number 2. The population of a town is 2,000 and it increases at a rate of 3% per year. Determine the population in 4 years, and is the growth linear or exponential? This is a growth that's a percentage every year. It's not the same absolute amount. It's the same relative amount every year. So that is exponential growth. Let's see. Year 1, the starting amount is 2,000. And how much is going to be added? Well, it's going to be 3% of the 2,000, which means that there's going to be 60 people added. So I have 2,060 for my ending amount. Year 2, my starting amount is 2,060. And now I'm going to be adding 3% of this number. 3% of 2,060 is 61.8. Now I'm not going to round yet. I'm going to wait until the end to round my answer. So now I have 2,121.8 people. So the beginning of year 3, 2,021.8. And I'm going to take 3% of that number. And that's going to give me 63.654. So I add this 63 to the starting amount, and I have 2,185.454. And in the start of year 4, I've got the 2,185. And I'm going to take 3% of that number. And that's going to give me 65.56362. And you don't have to take it out to that many decimal places if you don't want to. Come over here to the ending amount. We're going to round to the nearest whole number, 2,251. What I want you to see here on problem 2, the amount that's added every year gets bigger and bigger. We start off with 60, then we have 61.8, 63, and 65. So this is an example of exponential growth. Problem 3, the value of a tractor is $50,000 and the value depreciates at a rate of 6% per year. Determine the value of the tractor after 3 years, and is the decrease linear or exponential? Well, because it is based on a percentage, it is exponential. And I do need to point out something here about my headings, the year, the starting amount, instead of amount added, because this depreciates, we're actually having the amount subtracted. So starting with year 1, we have a tractor that's worth $50,000 and it depreciates at a rate of 6%. So I take 6% of that 50,000 and I have 3,000. So I take that amount, 3,000, and subtract it from 50,000. So now my tractor is only worth $47,000. And then that's my starting amount for year 2. So I take 6% of that, and I have 2,820. So that's 44,180. And then that's the beginning amount for year 3. And I take 6% of that, and I subtract. So $2,650.80 is how much I'm going to subtract, and that's going to give me $41,529.20. For the tables that we have done in this lesson, it's not taking us too long to get to the answer, but there are formulas that we could use to help us to get straight to the answer without having to do all these tables. And that's especially useful if we're going out, say, 10, 15, 20 years. So the next chapter, we're going to be starting to look at these equations or models of linear and exponential growth.